Hey folks, I'm Demotro, and today I want to tell you some things about what I call pre-Threeven throdd numbers, which I will explain in a moment. And I'm doing this bonus video here in my room, typing on my computer, kind of like the way I do some of my streams, because it's raining outside in the outdoor classroom, and because I have company from one of my very nice cats, Dandelion there, and because the way I wanted to present these facts to you folks is sort of in the form of a problem or puzzle that I created that I will problem solve through here in this video to give you these facts as well as some problem solving techniques. And this also relates to something I'll tell you about that's upcoming in combo class that I'll explain at the end of this video as for why I'm putting the facts in this particular form. But in any case, this puzzle that I'm going to solve here is to find the only number in the range from 200 to 2000 that's what I call a pre-Threeven throdd number, as well as being at least one of these things. And I'm assuming that most people who are still watching this video know what most of these are. To recap, square numbers are where you have another whole number times itself makes a square number. Triangular numbers are the sum of the first certain amount of whole numbers, like 1 plus 2, or 1 plus 2 plus 3, or etc. Named that because you can draw them with dots in rows that make a triangle, which you actually can do for square numbers as well to create a square, because both of these are types of polygonal numbers, a subset of what's known as figurate numbers, which we will cover in the future. And factorials are similar to triangular numbers, but using multiplication, like 1, then 1 times 2, then 1 times 2 times 3, and etc. The numbers those create are the factorials, and powers of 2 are 2 to some power, like 2, 4, 8, 16, etc. Now, pre-Threeven throdds, the term that not everyone would know, although people who've watched some of my videos might, are a term that you could kind of guess the meaning of if you didn't know it by looking at the linguistics here. This looks like even, that looks like odd, that looks like 3 is involved, and you might be able to piece together yourself that Threeven numbers are similar to even numbers being multiples of 2, but Threevens are multiples of 3, and that throdds are the whole numbers that are not Threeven, which come in 2 types, because if we were to look at some whole numbers, we'll notice that every third one is Threeven, and that all of the others could be described as 1 after Threeven or 2 after Threeven, but the ones that are 2 after a Threeven are also 1 before the next Threeven. So we could call them 1 after a Threeven, 1 before a Threeven, or Threeven for all of those, which is why I nickname the 3 types pre-Threeven throdd numbers, post-Threeven throdd numbers, and Threeven numbers. Now, there's going to be a lot of pre-Threeven throdds you can imagine in that range. There's going to be hundreds. And so to try and comb through them using a calculator or something wouldn't be too much fun, and it would take a lot of time, and we actually don't need to bust out a calculator. We can solve this just with our brains and, maybe a little bit of arithmetic by hand. And to solve it, we're going to start by wondering, this question seems almost too vague. To have just one of these types of number be required, as well as be one of those ones with hundreds of options, it seems like many numbers would fit this definition. But the question's telling us that there is only one in that range, and I designed the question and it's true, we can trust it. So we know that somehow there's not a ton of numbers that fit this definition. There's only one, and that maybe that means that some of these aren't a possibility at all. Unless the answer is all of these traits, then there would be some of them that were impossible to have a pre-Threeven throdd in that range. Otherwise, there would be a second answer. So, if we go through these and wonder, well, for each of these, are there any that are impossible to be a pre-Threeven throdd or to be one in that range? Well, we could check factorials and note that when we're going through factorials, as soon as we get to the third one and onward, we are going to have a times 3 somewhere in there, with no other pluses to change the fact that that times 3 makes it a multiple of 3, makes it threeven. So we'll note that the third factorial and onward are all threeven, so they don't fit the pre-Threeven part of the definition. And that 1 here is also not pre-Threeven, it's post-Threeven for the type of throdd. And 2 here turns out to be the only pre-Threeven factorial. And in fact, these are the only throdd factorials. And so 2 is far too small to be in that range. Given that this is the only pre-Threeven throdd factorial, and it's not in that range, we can note for factorials that it's impossible. We can't have a pre-Threeven throdd factorial bigger than 2. So what about these other ones? Well, for triangular numbers, the way that it's going to help us to crack this is going to be to remember that when we're asking about pre-Threeven throdds, and we're wondering if numbers can be that trait, we're somewhat in this land called mod 3, within what's called modular arithmetic, where numbers work around like a clock, basically similar to remainders upon a certain division, or similar to the last digits of numbers in a certain base. And so, if we look at basically the remainder after being divided by 3, that all of the whole numbers would have, we're going to note that 1 has a remainder of 1, 2 has a remainder of 2, 3 has a remainder of none, and that pattern will continue. And with this pattern, these are what we can say the list of numbers, whole numbers from 1 upward, is congruent to in mod 3. And the whole numbers from 1 upward were what we were adding for triangular numbers. So if we see the sums of these that have occurred, well, we'll note that if we have 1, that is still just 1. But if we have 1 plus 2, which would give us 3, well, 3 is 0 in this land of how much remainder do you have after division by 3. And so the first 2 numbers here make the second triangular add up to a threeven, which gets us 0. 1s are essentially post-Threeven throdds, and the 2s are essentially the pre-Threeven throdds that we're looking for. But we're not just looking for them among the whole numbers here right now. We're looking for them in the triangular numbers, which are collective sums of those. Now, if we want 1 plus 2, which gave us 0, and then we add another 0, we're still at 0. Then if we add all that same thing but add another 1, we're at 1. Another plus 2 gives us 3, which sends us back to 0. For those confused about modular arithmetic, there is an episode on the main combo class channel that covers a bunch of those basics called Modular Multiplication Magic. You might want to check out. And what we're doing is noting that these don't matter in the later sum because they added to a 3 that has a remainder of 0 for its portion, and this keeps it. So our pattern sort of goes 1, ooh, I'm back to 0, still at 0. 1, ooh, I'm back to 0, still at 0. So what this actually tells us is that the triangular numbers go post-threeven, threeven, threeven, post-threeven, threeven, threeven, etc. in that pattern. And there are no 2s here. 2s are the pre-threeven throdds. So although we have 2s in the whole numbers, of course, numbers that were 2 more than a multiple of 3, but also could be considered 1 less than the next multiple of 3, the pre-threeven throdds, we don't have any of those in the collective sums of those that the triangular numbers were. So, triangular numbers cannot be pre-threeven throdds, ever. So that's impossible too. Now, what about square numbers? Well, we're going to use modular arithmetic, but we're going to use it in a slightly different way. Square numbers are composed of something times itself. So let's make 2 different axes for a little multiplication chart. But instead of making our multiplication chart have to cut off at some point because it's a normal type and just know that, okay, there's more multiplication chart past there that we're not able to cover, what if we had our chart loop around modularly? Like we have the table be in mod 3 so that I'm only noting 0, 1, and 2 as possible things that you could have as a remainder after division by 3 if you were a whole number, or the values you could say you are congruent to in mod 3. Also standing for, threeven, post-threeven, pre-threeven. Now, if we put these on 2 different axes, we can create a little multiplication table in here. And that can work similarly to multiplying normal numbers and then seeing if we get an extra remainder. 0 times anything makes a row of zeros, as well as a column. 1 times 1 is still 1 here. 2 times 1, or 1 times 2, gives us 2. But 2 times 2 here gives us 4, which in mod 3 goes back to 1, because 4 has a remainder of 1 if you divide it by 3. 4 is a post-threeven. So we get a 1 there. 2 times 2 in mod 3 sends you back to 1. So this is the interior of the times table, or multiplication table. And our square numbers, much like a normal multiplication table, since they have to be the spots where a number multiplied with itself somewhere here, they have to be on the diagonal. They have to be etc. right on the diagonal. And we notice the diagonal only contains zeros, 1s, and another 1. There are no 2s in the diagonal. Just like before, a lack of 2s means, if it's impossible for this diagonal to have a 2 or to be pre-threeven, then it's impossible for a number times itself in this mod to become pre-threeven. And that gives us all the data that no square number, which must be the square of some whole number that was either threeven, post-threeven, or pre-threeven, can end up with the remainder of 2 in this land, or end up having the title pre-threeven. No square number is pre-threeven, just like no triangular number is pre-threeven. Impossible. So it must be the powers of 2. And at that point, we can note, well, powers of 2 grow pretty quickly at a certain point. There's not going to be that many of these ones in that range. Factorials there also would not have been many of, but there would have been a bunch of square and triangular numbers in that range to check. Powers of 2, we can note, well, let's say, what's the biggest one you could imagine? I happen to randomly know more, but let's say the one you could imagine is 64. That's the biggest power of 2 we can imagine. Well, you can double that by hand a few times. 128, not quite in the range yet. You could double that with some little arithmetic on paper. Get this. Okay, that's in the range. Double, double, and the next one would be that, but that's out of the range. So that's not a contender, does not fit that range criteria. So it has to be one of these. Now, how can we figure out which ones might be pre-Threeven? Well, do you remember how Threeven numbers we've mentioned in some of my videos before, the multiples of 3 in our base 10 system, if and only if you're Threeven, your digits add to a Threeven number. We can actually use that to say if this is pre-Threeven, we would be able to add 1 to it. Let's say, what are they? Plus 1. And whatever these are, plus 1, if they were pre-Threeven, will now be Threeven because they were pre-Threeven and will have its digits add to a Threeven number. So all we need to check is which one of these, when we add 1 to it, does the digits add to a Threeven number. And here if we go 7 plus 6 is 13 is our digit sum plus 1, not Threeven, not a contender. What about from the other end? 1 plus 2 plus 4 is 7, plus 1 is 8, not Threeven, not a contender. What about this? 5 plus 1 plus 2 plus the extra 1, 9, Threeven. In fact, also makes it a multiple of 9 due to a similar pattern. So we know that this number is Threeven, the plus 1 version, meaning we know the version without the plus 1 that was the power of 2 is pre-Threeven. And so 512 is the only number between 200 and 2000 that is pre-Threeven. The throdd is implied if I say that because, you know, throdd means not Threeven. It's just the vaguer add-on. That is pre-Threeven, and even just one of these traits because the first 3 were impossible. So I wanted to tell you guys some facts in this video, like square numbers can't be pre-Threeven, triangular numbers can't be pre-Threeven, factorials all become Threeven very quickly, although that one's a little more obvious to get at first. But I decided to put them in this form instead. This, almost like a question, although it's not phrased as a question, sort of little puzzle or problem that almost looks like it would be a test question or something like that if you had a relatively fun test. And the reason I did that is because this is actually a sample question that I was going to put on the combo class grade -1 final exam, which there will be. I've been hinting there's a transition to grade -2, and trust me, I hate tests too. Tests are overrated in our society. They dictate too much. Grades should not be as dependent on test scores. They also do not judge your ability in a certain skill. The work you do, not what you do on that singular test, can show merit, but test answers very rarely are a true judge of someone's intelligence. And that's coming from someone who was good at tests. I was good at them, but I think they're a problem for our society. However, I think there's one good thing, which is it makes you comb through certain types of material and make sure you've really digested certain big scale concepts. And if there were tools that you saw, try to use them yourself and make sure that you know how to actually work with the tools. And that's why there's a completely optional final exam coming up. I'm going to put it out on the main channel in a video about a week and a half or so from now. maybe 2 weeks or so from now, because there's still one more episode coming before that on the main combo class channel about a cool mix of math and language. That'll be coming out in a few days. But our final exam one, which will be coming out in a week and a half or two, and which is the second last episode of the grade, because there is a crazy finale episode too. The final exam will probably scare a lot of people away from even trying it, but I feed you folks so many answers in my videos. I think it's time to make sure that some of you can try using some of these things yourself. Not really to see what you've memorized, although there are terms that you may, have to have remembered, but more so to see, are you able to calculate a certain type of thing that I would have fun calculating? And so there's going to be an optional test with the answers coming out like a week after. The test will be released in a written form and will be first released in a video on the main combo class channel at that time. The answers will be in a bonus video that you don't have to click on until you want to, here like a week later on this Demotro channel. And I recommend that if you think you might ever want to do the test, don't click on the answers right away. Even if you're not going to do the test right away, you might want to wait until you've seen most of the episodes on the main channel. There will be exactly 36 episodes in grade -1 on there. The base 6100. And at that point, there will have been 34. And every question on the test will be something that if you watch the main channel, you'll have all the clues of any term, any tool, and etc. you'd need. The things will probably have been mentioned on this channel as well, but will definitely be something that was mentioned in one of those main channel episodes, the combo class channel, which is linked in this description for anyone who for some reason isn't subscribed. And you could wait if you want to watch those episodes later, wait until you've watched most of them, then try the test, then look at the answers just for the questions you give up on. But whichever questions you want to try out of the test, I think that you'll find it really engaging and good for your brain. It's not just going to be memorization. There will be little tools you may have had to pick up from the episodes, but each question, or at least most of them, will hopefully require you to do a little bit of problem solving, a little bit of calculation, like a semi-milder version of what I just did in this video. So the questions might look something like this. Although this is dense enough, I probably would have split it into a few questions if I'd kept it on the test. There will also be some weirder questions, or, things to do to get a good grade that I'm not going to explain right now. You'll have to see, but it's going to be a different test than one you've ever seen for sure. So stay tuned to that, even if you hate tests like I do. Maybe you'll enjoy this one. And it's not graded or anything. I will maybe make a point score if you want to self-grade it, but it's not required or anything for you to be one of my combo lords here. Just recommended that it would be great for your brain. So I'm having fun making that this week. Like I said, there's also another episode coming out in the main channel first in a few days about math and language combined, basically about weird properties you find when looking at how numbers are spelled. And, oh, Dandelion's up. Hey, Dandy. Ooh, that's a good soft boy. And if you want to catch me some more, check out the Discord, subreddit, and Patreon that are linked in the description here. If you do want your name on a whiteboard in the finale episode after the test, then within the next week or so, within the next 2 weeks or so, we can say, get on the Patreon or try and send me some special request if you're a hyper super fan. And I'll be putting some people's names on the whiteboard, including all the Patreon supporters, on a random whiteboard when I'm thanking people. And look at that nice dandelion. He's such a sweetheart. So, I'll catch you folks again soon. Thank you for watching. And remember that I found all of this stuff when I was making up test questions and just wondering about what are ways to create problems like this. And it forced me to test out some of that stuff and some other stuff that didn't work out as miniature tests, stumbling around to find this answer that I showed you guys. And I think problem solving is great, and maybe some of you will enjoy the test. In any case, I will catch you again soon, and let's get one last little look at this very soft cat's stomach.